So MoreNPBiz project is about energy and quality efficiency of drying of plant-based materials, and our project partners, you already saw the introduction from both from Finland and Sweden, Centria, Oulu University of Applied Sciences, and Luleå University of Technology, and Huusholm Sells Carpet. And I have here a short summary of the project results, and you will hear and see more details in the introductory presentation. So a mobile dryer has been designed and constructed, although some adjustments are still being done with a mobile dryer, and a demo dryer has also been designed and constructed, and also adjustments are there ongoing still as well. Recommendations for dryer entrepreneurs have been written, and a commercial dryer Oracas has been updated, and design and instruction for the construction of a modular dryer and an economic flatbed dryer has been done. Also, recommendations for the drying temperatures of nettle, birch leaf, and rosewood have been written, and quality characterization methods for those plants have been developed, and also a waste energy map for drying has been developed. So I let Mikael to continue with the your work regarding modeling at LTU.
Come to my presentation. I will talk about the modeling and design of the demo drying unit in Piteå. So you can go directly to the next slide. So I will first talk about why we do modeling before we build it, and then a little about the construction, and then some results from the first drying test we did. So why do you do modeling before you construct something? We use CFD, so then you're solving the fluid flow and heat transfer using numerical analysis. So you divide it in millions of cells where you can calculate the airflow, and then you can find out the flow in the dryer. So why do you do that? If you compare, for example, experimental, you build a dryer and then you test it, and then if it don't work as you expected, you need to rebuild it. And often this is very expensive, so it's good to have done some preliminary pre-work by using, for example, numerical methods. Another thing, you can do analytical, but then you cannot handle the difficult geometries like you have in the dryer only. But it's very good if you want, for example, calculate pressure drop in pipe flows and stuff like that. Then you can do analytical and don't need CFD. So we do this to complement. First, we do the design, and then if we want to change something, we can also look at that, and then we build our dryer, and then we measure, does it run as we expected? Is the airflow according to that? And you get the results like this. This is the two different parts that we have looked mostly into when we design the dryer. The left part is the inlet to the different drawers. If you don't design this correctly, you will get bad airflow in the different dryers. For example, you can get most airflow in the bottom. And also we want the flow through the drawers is in the right image to be very even. So then we look how we should have the inlet to the drawers also. You can go to the next slide. So this is, we see the drying, the dryer before and after we did the optimization. So this is from the left side. You're standing on the left side and looking at the dryer, and then how the air goes into the dryer. And this is the velocity. So blue is low velocity and red is high velocity. So first, before we optimized it, it was very much air in the bottom and very little in the top. And then we optimize it and we get the much more even distribution in the dryer. And then from this, we build the dryers that look like this. So it's the air comes in to the left, goes to the drawers, and then out to the right. And then you have the possibility to recirculate the flow. And then we did some preliminary tests with leak, and also we did some baby spinners test last week that we have not evaluated yet. So if we go to the next slide. So the results here is we look at how much water that is removed at different time steps, different times. So you see the first write-in is after, I think it was 1 hour, and then it was maybe 4 hours different, or I don't remember exactly. And then we look how much water that have been removed from the leak. And you see here, the waiting 6, that is the light blue color we did for all the different drawers in this. And you see for the first one that is in top and the bottom 2, it's little worse compared to the other one, but it's quite good distribution of the drying. So we get quite good air distribution in each drawers. So then you don't need to change or stop the drying in the middle and change the drawers. So you move the one from the bottom to the top or something. That is very common in a lot of dryers. And then this is only how it's look when we run it for, I think this was almost 1 day with drying the leak. The leak was quite hard to dry, so it was some water left, that can we see. So this is the difference between the inlet and outlet in the absolute humidity. And if it's finished, it should be 0 different. And we see we still have some difference in the end after 24 hours. So we maybe need to dry this 1 or 2 more days to get it dry. But we currently, last week, we look at the baby spinners to how it's are dried, and also we look how much and more energy efficient the dryer is when we use the recirculation. So we did 2 more tests with recirculation and 1 without, to able to compare how energy efficient this dryer will be in the end. So thank for me, and if you have a question, you can ask them later.
Okay, thank you, Mikael. Then Håkan, please, you can continue.
Thank you, Lena. As I said, my name is Håkan Landström, working at Hushållningssällskapet. I will start to say a few words about our role in the project. We see ourselves like the link between research, development, and entrepreneurship. We have chosen to be a part of the MoreNPBiz project because we believe that drying and picking can contribute to new jobs, especially in rural areas, but also that drying can create positive effects in the cities in form of new, exciting and healthy products. I can see some business here in the future. The demo dryer in Agropark Öjebyn. A matter of fact, after several years of work with a MoreNPBiz project, and also I have to say a fine collaboration together with Luleå University of Technology and Centria in Finland, we finally have a drying plant on site in Öjebyn in the municipality of Piteå. The overall idea with the dryer, at least from my or our perspective, is to create a positive development for drying herbs and berries in Norrbotten. We want the drying plant to be a hub for established companies, but also contribute to more people daring to invest in drying as a business concept. To make drying of wild growings in a reality, you also need someone to pick the herbs and berries. And we seriously hope that in the long run, that we have new businesses running out of this as well. A few words about the dryer in Öjebyn. The dryer is about 2 meters high, and about 1 meter in circumference. It has 20 drawers, which means that you can dry relatively large batches. The temperature in the dryer extends up to 50 degrees Celsius then, which in most cases is an optimal drying temperature. Already today we have several companies that want to use the drying facility in Agropark Öjebyn, and we are working with an organizational model for a more commercial drying operation in the future, and I will talk more about that in the next slide. So please, Lena. We have actually identified 3 potential clusters, actually 4, because I can easily add Kalix River Valley to this slide. What we can see out of those 4 clusters is that they are quite small scale operators. In some of the cases we can see some bigger operators as well. In Jokkmokk we have an ongoing cooperation between the operators. We can see a willingness to grow and a supportive business advisory service as well. In Tornedalen, we have, as I said before, small-scale business concentrations with food, and they are also very interested in developing new products. And in Tornedalen, we also have a berry center, which is really interesting from a drying point of view. And of course, Öjebyn, where we have the dryer, the demo dryer, it's a center for innovation and test beds for the green sector in general. Please, Lena. The assessment made during the project period is that a drying association or a drying collective should be established, and we have some evidence for that as well. We also want that association or cluster or collective to initiate competence development, of course. And we also would like to create a platform so we more easy can exchange skills between companies both in Sweden and Finland, maybe some other countries as well in the future. And one of the more established players in Norrbotten in terms of herbs and drying is Eva Gunnar with the company Essence of Lapland. And Eva agrees with the thinking about a formation of a drying association or a drying collective. Eva emphasizes that the importance of carefully thinking through the booking model. And here we have a bit to go. As much of what is dry takes place during a limited period of the year, and the pressure on the dryer will be quite large on a limited time during the year. And Eva also see a lot of interesting development in terms of new taste recipes, for example, tea and species. And what we can see in general is that we have a trend in terms of vegetarian diets and also in drying, of course. And this can easily be a very interesting area for development. You can change the slide. So there we go. Thank you for your interest.
Thank you, Håkan. And we can continue then with Antti's presentation.
Okay, so I'm Antti Takalo, like I before told. So I was also responsible responsible of this drying series we made at Centria, and also about these waste energy sources for drying. So I was looking for simple resources for using waste energy as a heat supply for drying. So here I have gathered some information about possible situations. One for large scale options would be this district heating plants, which almost give away this return heat that they can't use. So it's inexpensive way to use in large facilities, and you get the energy with half price, but the investment costs at beginning are a bit higher, approximately 50% higher than with normal district heat, also depending on the location of your business. Then the more and more becoming CHP plants, they are gathering popularity among us. So in meaning using the CHP plants, excess heat means the heat that comes at certain time of a year, because they are mainly measured so that at cold time all the energy is used from CHP plants. The excess heat that comes at summer and autumn time is normally at heating use in summer winter time. So it's seasonal, but it's still good, and it's easy to plug in. Then these food treatment facilities are one that are existing there and there. So they have a lot of excess energy from cooling and large heating systems. So you can easily plug in if the other part wants it or gives away the energy. And overall, it can be found almost everywhere if you look for it and pre-plan it. Here we have this costs and connections. So like I told, the beginning costs with this district heating is a bit higher at the beginning, but the good case, you can get the energy with half price, so it will pay itself back. Also, depending on your capacity, what you're using. Then almost every other method of using waste energy is varying how user wants to set up the system, but it's meaning that how largely you want to use the waste heat. So if you have large facilities, normal cases that you can't take it all. Then some prices I took up. These are just price parts as an example for setting up a waste heat system with a water circulation based source. So heat exchangers for plug-in is 5 to 50 kilowatts. They are quite inexpensive, like all the other parts. On top of this, of course, you will have to consider building the system. So somebody has to design and build up the system, and that is all relative to the construction you are making at the moment. So I can't give a price for that, but the part prices are not that expensive. But then again, there is this building costs. But normally in these cases, you can get the energy for free. Also a matter of negotiations with the other party, but that's the normal case in these smaller cases. Then hygienic factors in using waste heat. So normal cases, if you use water circulation, it's good to use, but if you are using air supplied waste heat, it's a bit harder to harness. So normally you can't just use it straight up. You have to filter it, separate it from these other streams, because there is normally some impurities inside the airflow, and it can clog some heat exchangers if you have air to water heat exchangers, or then if you have just using it straight up for drying, it can contaminate all your products, so please not do that. Then water circulated systems are a lot easier to harness. So I would recommend that if you get these fans running on some roofs and you want to use that to your drying, that's a good case. It's easier to plug in. Then among these waste heat solutions also have to be concerning about the environmental factors. So can the actual environment contaminate your product? So, and if it can't contaminate your product, okay, is it still good for your imago? So is a industrial location actually suitable for natural product business? I don't know. Maybe it is in some cases, but it does not give a good imago, so it might not suit for purpose, although waste heat would be supplied fairly easily. Then we had this developments of a modular dryer. So this dryer is set up for using waste heat. We didn't find any already existing models of dryers to use water circulated heating, so we designed one. And this uses same kind of principle that Öjebu Agrobart's dryer uses. So we have a horizontal airflow, so we get optimized airflow in every tray, so they should be simultaneously ready and as dry as the other trays. And then it's designed to be used in okay, maybe at one cabinet, but it's designed to be used as three parts. So you can first dry the free water at the lowest energy content area, and then partially bound water in a mid chamber, and then the end drying is made nearest to the heat here to the radiator or the heat source. And area and capacity of drying in this can be loaded 3 centimeters thick layers. So here we have some little less than 5 square meters of drying area. And if you take 3 of these, you have quite a large capacity. Yeah. Then the most recent that we had designed is this updating and design of flatbed dryer. So in the drawing at the right, we don't have the vents that there is going to be at the bottom of the dryer. So there's going to be these air spreading vents on top of the holes, so that the airstream will be even in these sections. And the original suit of this flatbed dryer was for grain, so it was with one bed and not that much of sophisticated control of temperature or airflow. It was just heated with wood, and air was blown through the bed approximately some amount, no knowledge of how much. So now we added 4 vents. So every of these 4 sections of the dryer have own vents, so you can actually adjust the airflow to be even though you wouldn't have actually same amount of material in every box. And then we added these recirculation channels to this flatbed dryer. It's on the right of the dryer bed. There's these thin holes that you can see from the picture. Can I actually point out with this one? Can you see the cursor? Yes. So here is small vents that you can see. So it's recirculating air from this back to the heater unit, so we get more efficiency. And the idea is that it's covered with partially punctured covering with either plastic or some other kind of a covering. Maybe plywood can also do that. And then there's this other matter that we noticed during playing with the dryers is that the importance of the airflow direction in the dryer. And these ones. So, yeah, normally if you are going to buy this dryer from markets, there's these general configurations in all commercially available dryers. So normal setup is that you have heater at the bottom and the airflow is from bottom to up. And shelves holding products are horizontally. So normally you have 3 to 6 shelves or more. And that causes some variation within airflow and variation within temperature. So we made some adjustments in our drying tests, during our drying tests, and we solved these typical problems. And we also made this this power consumption a bit lower. And here's our, I'll take these up. So we started with a normal Oragas dryer, which had a pretty poor thermostat, which had a ±10 degree variation in temperature control. So we updated the thermostat to this Omron thermostat, and we got ±5 degree gain in the temperature control. Then after that, we bettered the airflow, and in this case, we just tilted the dryer to horizontal level and made some spaces so that the airflow can go between the gaps. And by turning this, we bettered the drying time, so it's even in every level. So you don't have to mix the shelves within the drying time. So here we have some data from this update. So at the left side, we can see the old bimetal thermostat. So it's pretty rough curve. And at the right hand side, we can see the new Omron electric controller, which is much more better for accurate use, even though it has its variations. It's much more lower than with this bimetal thermostat. And then here we have also the horizontal temperature variation between exit and enter of the air. So at right hand side, you can see the horizontal view, and left Oragas as a vertical. So you will always at the vertical position have this variation between exit and heater end of the dryer. Then we also made some enhancements with the energy consumption by adding an air recycling channel that's rather simple. So first of all, in original state, the dryer will only blow the air once through the batch. And in our ideal case, it would do it a bit more, and we recycled the heated air just with the veneer box on top of the dryer, and we gained some approximately 40% reduction rate of energy consumption in this case. And in this small solution, it was really inexpensive, 5 to 10 euros. But in a larger scale, you will always have to invest in piping and installing more, but it's still rather cheap cheap way to save energy. And here we have this dryer without air recycling. Here we have dryer cooling faster than heating. So we will always be heating it more. And here other dryer we have this cooling cycle slower than heating. So we can see that it's heating up much faster than before. It's using much less energy within the heating time because it's faster. And again, it's cooling slower, so the temperature variation can't get that high.
Thank you, Antti. We can continue with the quality introduction to quality and the work done in the project. So please, Evelina.
Yeah, hi everyone again. I'm Evelina Isosaari, and I'm going to interrupt this drying and dryer talk with quality talk. So I will talk about quality in general, and then I'm going to tell you a little bit that what we observed during our drying trials here at Centeria. So plants, as you know, they contain many chemical compounds that affect the healthiness of the plant, the color, taste, and scent properties of that plant. And the chemical composition in those plants varies depending on the species, growing conditions, for example, weather and soil conditions, geographical location, and growth stage. Growth stage meaning, for example, ripeness of the plants. However, when you process the plant into a product, the chemical composition of the product varies as well. So it varies depending on how you have harvested and when you have harvested the plants and how you have processed the plant. Have you frozen it, chopped, milled, or dried? And competition in the market in price is really hard, but you can stand out in the market by investing quality. So you should consider and think if that is a way for you to enter the market or to stand out. And when you start to think about these things, there are a few questions that you should consider. What is your material and when you are harvesting it? For example, when we dried nettle, we observed that early summer nettle, fresh new nettle, had higher contents of these polyphenols, which are affecting human health, than the late summer nettle. And similar thing has been observed with birch leaves. So it is important that you harvest the material in the right time. And in some materials, for example, in berries, you don't really have an option. You have to harvest it when it's ripe. But in some materials like leaves and roots, you can consider if you harvest it in the beginning of the summer or in the end of the summer. And in some materials, it's really material dependent. It may not matter that much that when you harvested it. And when you process the material, you should consider if you can process it as fresh. So when you have harvested it, you go straight to drying, for example. So you don't freeze it and then dry it. And again, with the nettle, we noticed that when we put fresh, newly harvested nettle into the dryer, the contents remained better than in the nettle that we froze first, let it be in the freezer for a few weeks, and then we dried it. But of course, if your harvesting period is really short, you may not have an option to try it as fresh because you have to pick and harvest the material really fast. And if you process the material by drying, you should consider what drying method, so with what kind of dryer you want to use, because there are differences between the dryers. And I will tell you more about differences between the dryers. Also, there has been a lot of talk of the optimum drying temperature. So you should consider in what temperature you want to do the drying and when you should stop the drying, when the product is dry enough. So in this project, we did drying tests. We used 3 different dryers, vacuum dryer, and this convective dryer, Oracas, and then normal heat oven, like you have in households. And we tested drying temperatures from 40 degrees to 80 degrees. And we measured polyphenol content and antioxidant capacity of these dried materials. Polyphenol contents, they are compounds that have supposedly positive effects on human health, and antioxidants as well. Many polyphenols behave as antioxidants. And polyphenol term may be new to you, but they contain many compounds that are already familiar. For example, anthocyanins in berries. So here we have the polyphenol contents measured from the nettle leaves, birch leaves, and rosewood that we dried in those 3 dryers. The blue columns, they represent material dried in a vacuum dryer. The orange columns represent material dried in convective Oracas dryer. And then the yellow columns represent normal heat oven dried material. As you see with nettle and birch leaves, vacuum dryer gave much higher polyphenol and antioxidant contents than the other dryers, heat oven and convective dryer. And the reason for this is that material is less in contact with oxygen. And for example, a freeze dryer has same thing, so the material is less in contact with oxygen because it's in vacuum. So that clearly improves the content of polyphenols and antioxidants in the material. But in rosewood, for some reason, there wasn't difference between the dryers. So the contents are quite similar between the heat oven and convective dryer and vacuum oven. And the difference between heat oven and Oracas is small, but you can still notice it in nettle leaves and birch leaves. But there isn't notable difference between the temperatures. In nettle, the contents are quite even in every drying temperature, a little bit higher at 65 degrees, but quite even. And in birch leaves, there really aren't any differences because when you try and measure natural materials, there are some variations in the results. But with rosewood, it was actually noticed that a little bit higher drying temperatures were better. That can result, for example, from the fact that when you have a little bit higher drying temperature, the material is and the matrix of that plant is more decomposed, so the compounds are more reachable in extraction and measurements. But what we can conclude from this is that dryer has a greater effect on polyphenol content and antioxidant capacity than the drying temperature. So besides thinking of drying temperature, it's important to think that what kind of dryer you are using and can you optimize the dryer in some level to improve the quality. And you can use a little bit higher drying temperatures than you have used to, because there wasn't significant decrease in quality. In some cases, as we saw in the rose root, higher drying temperature actually gave higher results. But of course, when you optimize drying temperature, you should consider that what you want to store in the product. So if you want to prepare product from plants that is used as an aromatic scent, that has a lot of easily evaporating compounds, sensitive to temperature, same drying recommendations and temperatures don't apply. That applies to product that you want to store polyphenols at. So you should consider what are the important compounds in the plant, what you want to observe, and how the plant is used. Do you want to store the compounds affecting the health, or do you want to observe the compounds affecting more to the color and scent? Because it's really compound, it depends on the compound that what is the optimum drying temperature. And I recommend that when you select the drying temperature, that you should do some temperature tests, because you can easily observe color, taste, and scent of the dry product by your own senses. So you can see if the quality is good when you dry at 40 degrees or if you dry at 80 degrees. But if you want to verify the content of chemical compounds, you should verify them through laboratory analysis. And after you have selected the dryer, the drying temperature, of course, there is question then when to stop drying. Normal recommendation is that end moisture content of 10 mass percentage is suitable. So you can have 10 mass percent of water in the end product, in the dry product. If you dry much under the 10 percentage, it may not have any effect on the chemical composition. For example, we didn't notice that even though we dried much under 10 percentage, that the polyphenol content or antioxidant content had decreased. But of course, the more you try it, it can cause some changes in color or odor sense of that product, because some heat sensitive compounds could degrade or evaporate. But more likely, if you dry much under 10 percentage, the biggest of your worries is that you just consumed unnecessary energy. So the more you dry without any reason for it, of course you lose energy and time. And drying much above 10 percentage is more harmful, because if there's a lot of water left in your product, it will shorten the shelf life of that product, because the more water you have in it, the more early the mold and microbes start to grow in it. And that was it from me, so thank you.
Thank you, Evelina. And we can then continue shortly with Jaana's presentation from Oulu University of Applied Sciences.
Hello. It looks like Mikael and Antti have emptied the floor already from me, so I can maybe take some time more to the studying of the business opportunities in plant drying. But in this slide, you see our tasks So with the plant dryers in the companies, and then the next task was the mobile dryer, and the third one was then the business calculations. And then Leena, you can take the next one. So as Antti and Mikael have discussed, the typical failure is in all dryers the uneven airflow if you do not adjust the design. So in flatbed dryers, usually the fan pushes the air towards the back wall, and that means that it will cost in uneven drying. So near the back wall, the material will dry very quickly, but on the front side there happens nothing. So we tested different kinds of we actually built more labyrinth to the air channels. On the left side you see a perforated fan air sheet in the air channel, and on the right hand side you see different small pieces of boards which influence then the evenness of the airflow. The second thing we found in the plant dryers is that mostly fans were too effective. So that's why our proposal was that a variable speed drive, which is frekvensomvandlare på svenska och taajuusmuuttaja på finska, that would be a necessary tool to avoid excess energy consumption. Report of this is available. This evaluation is available in the website, both in Finnish and Swedish. Helena Zimmer has translated and made corrections to the Swedish language. So please, Leena. Antti told you already quite much about the cabinet dryers and the problems of it, and several companies in Finland, they have a big Oragas dryer, and we couldn't help the entrepreneurs very much, so we asked help from an electrician, professional electrician, and with the collaboration of Amplans AB Oy, we will get one model of modernization of the old-fashioned technology in those cabinet dryers that are popular in Finland. And this will also be published with an estimate of the costs as well on our website. So the mobile dryer was built because many people have noticed how easily the plants tend to heat after they have been picked or harvested. And that's why it would be important to start the drying process as soon as possible, because heating will destroy part of our valuable components in the plants. So that's why we started to design a mobile dryer with which we can drive to the forest and then blow ambient air, so unheated air, in the beginning of the process. For this dryer, we also used the CFD simulation from Luleå Teknisk University, and which was really helpful, as well as we used also for one dryer located in Tervola in Finland, and it was also very good to use the simulation. So we bought for this dryer quite heavy heater, and many people say that this is absolutely too effective for us. You do not need such big, but we think that as we are going to locate this dryer in an unheated building, and we are going to dry probably maybe mushrooms or anyway products during the autumn, then heating air from maybe 10 degrees to 40 to 50 degrees would need more effective thermal input. So during the work we made several errors, and so we had a very ambitious design plan with a 2-layered machine, which would be twice this big as what we got. So this machine can take some 400 liters of fresh material. But as the construction work then proceeded, we noticed that, oh God, this 2-layer model will be too heavy for the trailer that we have in use. And that means that at the moment we have a too big centrifugal fan, but an appropriate heater. And with that we have to now manage. So Lena, you could take the next slide. But however, we have used this, we have tested this machine on the farms, both in Sweden and in Finland, or actually in companies, and drying parsley, what else? Chives and so on, many products. And the comments of the companies has been actually quite good. But we actually could not test the functioning of the machine on farms, so we had to do it in the lab. We added a recycling hose to the machine, so we could test also the same thing that Antti and the other our colleagues were doing in Centrias, and we here you can see in the picture that the energy consumption decreases after the recycling hose has been added to the fan. So we counted that approximately 20 to 30% can be saved in the energy consumption with this system. Well, then to another approach. So I calculated, made a model calculation for a company who dries and prepares natural products or vegetables, mushrooms, and so on for the industry. This kind of unit could be owned by a corporate of natural products, or an entrepreneur. And the unit works 6 months, and the volume is around 10 tons of fresh herbs or plants. And there is one person taking part or controlling the drying and doing the sorting. So I estimated that the drying and preparation can't be much lower than 2 euros per kilo fresh material in order to keep the business viable. And besides this activity, in this business, there has to be some other services like washing, extraction, or other activities run by the worker. But if we calculate what does the price mean for the dried product, so it would be then much higher than 2 euros per fresh kilo. It would be 12 to 14 euros per kilo. And this is actually quite much, as we know that the industry usually pays or buys the herbs dried with a price of 20 to 30 euros per kilo. So the prices are without MOMS or ALV, so without the added value tax. Lena, you could actually change the slide. Yes. So as I calculated that after this drying costs, what is left for the subcontractor, so for the picker or collector or harvester, then it will be only 8 to 16 euros per dry kilo, or 1.5 to 3 euros per fresh kilo. So what do you think? Is that enough? And for me, it sounds too little, because you are using quite much time to pick the material. So it's not easy to get 1 kilo of fresh herbs from the nature. So the price actually of this company is, or the costs of this company, the biggest costs are actually the salaries, 45%. And after that, in my model, the price of the machinery, so investing in all machinery, was about 20%. And the fixed costs, energy, and other costs were then the rest. So how to make this cheaper, this kind of activity or this kind of business, and so that the picker could maybe get a bit more money. So my suggestions are automatization of the drying process. So less controlling, less mixing of the materials during the processing, and so on. Absolutely bigger batches to be dried, and maybe the most effective one could be starting cultivation of herbs and special crops instead of extensive collecting. So, of course, certain natural herbs are easy to collect, like meadowsweet or well, I don't know the English words, but anyway, but then all that kind of products which have to be graved from like roots, they should be cultivated in order to get more easily high amounts of material. But what do we learn from this calculation? This, as my calculation, which is absolutely not true, as it's been read by several companies and several workers in companies, but it's not absolutely the whole truth. But I believe that this kind of activity or business could be already possible if for a half-time entrepreneur who has more activities during the winter and springtime and less for the summer and autumn time. Then and this kind of a unit would be realistic if we have several small farms around cultivating special crops, and then a certain amount of picking activists who pick products from the forest. And this model will be available on our website, as well as another model which I have calculated for a farm, a family farm who cultivates certain amounts of herbs and then uses natural products. And that might be also a more realistic calculation, because our natural product companies are mainly small. Thank you very much.
Thank you, Jana. Now we have gone through the introductory part of our work in MoreNPBiz project, and we have received some questions in advance, and here you can see these questions. So Evelina and Jana have prepared also answers. They will give those answers orally, and then we will also have some detailed answers on the next slides. So Evelina, please, you can start with the first question regarding Shaga.
Thank you, Lena. And please, other experts here, you can fulfill me in these answers. So the first answer is it okay to try to moisture content between 10 to 14? And yes, it's relatively good moisture content, as I already mentioned in my slides. And what happens from over drying? You can lose some easily evaporating compounds the more you dry. But if that's not an issue for the product, that those aren't the most important compounds in it, then over drying mainly consumes more energy than needed. And how can the moisture content be measured? In laboratory analysis, we measure the moisture content by placing the dried product in an oven at 105 degrees. So something you can create your own, these circumstances. And we let the product be in there overnight, at least 12 hours, and then we wait it. So we wait it before the oven, we dry it at least 12 hours in 105 degrees, and we wait it after it. And from that decrease in the mass, we can calculate that how much moisture was left in the product, and we get the moisture percentage. So that is one way if you have time to wait for the results, because that takes 1 day to get it. But there is also, for example, one way to measure it that you get the answer right away, but that includes this device near infrared region. So you can measure the moisture content left in the product in few minutes, but the device costs at least 2,000, 3,000, depending on what sort of device you want. And of course, you have to prepare an analysis method so that the device can tell the moisture content, so it doesn't automatically measure it. But if you have time to measure it overnight, then just do it in normal oven, 105 degrees, and bake the product. And the next question was that how much the moisture content varies between the surface and inside of chaka. Usually chaka, at least the products I have dealt with, have been dried in pieces. In size of those pieces is approximately 2 centimeters wide and 2 centimeters thick, or even less. So I think in those the moisture content doesn't vary that much. But do you, Jaana, have something to add to this?
Yes, usually tubers and roots, which are chopped to smaller pieces, during the drying process, there is a certain period in the middle of the drying process when we take the heat away and we only blow air through the material. And the idea is that then the plant has time to, or the moisture has time to diffundate, a scientific word, diffundate from the inner tissues to the surface, and like even and the moisture content on this piece, on the pieces, will be even then in the inner parts and on the surface. And then you continue heating after, let's say, it may be depending on the material and how big pieces you have, 1 hour to 3 hours, and then you continue. But there is very limited information about this. I have read one paper about this.
Yes, thank you, Jaana, for the addition. There were also questions about freeze drying. So what kind of materials have been dried, how the chemical compounds in the freeze-dried products preserve, what kind of analysis results there is. Normally, if you look for freeze-dried products from the stores, commercial freeze-dried products, they are berries and fruits. But of course, you can freeze dry any material that you would dry in a normal oven as well. The analysis results for freeze-dried material, there isn't that much comparison made with the freeze dryer and a normal dryer, but it has been observed that the color properties of the material of the plant are preserved better in the freeze dryer than in the normal dryer, because of the oxygen not being present in the freeze dryer. And also freeze dryer gives material more porosity. And I could not find many articles about how different chemical compounds are preserved in the freeze drying, but there are some indications that they are preserved slightly better in the freeze dryer than in the normal dryers, and probably that is also due to the oxygen not being present, because in the freeze dryer you dry under vacuum as well, like in the vacuum dryer. And also because the drying temperatures aren't high and you dry in vacuum, the easily evaporating compounds are preserved a little bit better than in the normal dryer. And the next question was that where you can do this analysis. Are there any laboratories for it? So yes, there are laboratories and institutes who can measure, but they are really hard to find. In Centria, we can, for example, analyze polyphenol content, antioxidant capacity, and anthocyanins from berries. But if you want to measure some specific compound, and we don't have method ready for it, you can always ask. And in some cases, we can develop the method if it suits our goals as well, or there is funds to do it. And other laboratories, I recommend that just ask from different institutes who you know or have heard that work in these matters, in these type of projects. But of course, normal commercial laboratories, such as Eurofins, for example, they can measure some vitamin contents and these kind of things that appear in every package, how much there are carbohydrates and sugars, etc. And next question was that, is there compounds in plants that help human health? Yes, but there are really strong regulations that you can't say in your packaging that this product improves your health, so you can't really do that. There are health claims being tried to being applied for these products, but it takes years of studying to be able to prove it and to get the health claim for certain product or compound. But you can tell in your packaging, for example, that your product contains a lot of vitamin A or a lot of polyphenols or antioxidants. Of course, this has to be based on facts, so you have to measure it before saying something like that. And also there were some questions that what sort of plants you can freeze dry. So if you're not sure if the plant is edible, you should look for that. For example, from I'm actually not sure of what these are in English, but in Finland we have this myrkytystietokeskus and also Ruokavirasto, which have quite good websites.
Food Safety Office.
Yeah, Food Safety Office, for example. Yeah, and then there is a European Novel Food Catalog where you can also search if the product can or the plant can be used as a normal product, for example, as an eatable product. But there is only one question left, and that was for Jaana to answer.
Yes, Leena, can you give me the next slide, please? So there was this huge question about drying materials in larger amount. And as we have been working with the drying of berries. So I listed here some topics. So quite often these berries, especially and as well fruits, are dried in heat pump assisted dryers on shelves, so kondenssikuivaus. It can be also with a traditional convective dryer, it can be done as well. And then one point to dry, especially fruits, is that they easily get brown during the process. So that's why people have developed different methods like dipping the material or fruit slices to hot water. This suits well with potato and carrots, but absolutely not with onions. And usually the fruit we can buy from the shops, food stores, are soaked in the dilute sulfate solutions, or even if you do not want to use sulfate, you can use ascorbic acid or citric acid, and try to prevent the browning there. So we have studied an alternative drying method, which is called osmotic dehydration. And there the active solution is sugar. So we have tested this only with berries, but I have read about the fruits as well, so I wrote them here. So the fruit slices are dipped in hot water, and then after that, those fruits are put in a strong sugar solution for several days, let's say 1 or 2 days. For the berries, it's if you put the berries in hot water, the wax peel will be destroyed and you lose part of the juice. And that's why the idea with berries and this osmotic dehydration is that you try to make this the wax peel of the berries a bit lighter, so that it will let the sugar solution suck the juice away, or the moisture away from the berries. So by putting the berries first in hot oil for 10 minutes, it's usually does something to the wax peel, and after that soaking the berries in a strong sugar solution for several days. So we have used mainly 3 days. You use after that you see that the weight of the berries have gone down quite much, maybe 20 to 50%, and then you can after that put them into a normal oven with a good, well, not normal oven, maybe better would be a good dryer with a good ventilation, and do the final drying. And then there is this normal way. What many entrepreneurs do is to dry natural wild berries as a puree. but then you won't get whole berries. You get only berry flour, which is of course good product as itself, but if you want to have similar products, like if you buy these Canadian or American berries, you can buy at the moment from the shops. Yeah, this was for drying fruits and berries. And Lena, I have still something here. Yeah, drying herbs in the best way in large amounts. So very much depends on how large is your production and what is the turnover of your production, because then you have to anyway be able to pay the costs of the investment. The largest or farms or companies which have a large production, like 10 to 15 hectares of herbs, they usually use belt dryers, which is expensive method, and there are several companies who sell these kinds of dryers, but they are really expensive. Then the flatbed dryer is a cheap alternative because you can design it yourself with the help of ventilation and heating specialists. Unfortunately, our heaters, which are easily available, they are for heating buildings, and usually it's difficult to find such heaters which can raise the temperature up to 60 degrees. So which would be nice according to what we learned from Evelina's talk. So but anyhow, you need a specialist to help you, and usually a ventilation specialist would be good to have. Then we have the heat pump assisted cabinet dryers, and they are usually 2 or 3 times more expensive than the flatbed dryers. So I would say that the production should not be too small. There's one example. There was a 7 square meter heat pump cabinet dryer, which the price was almost 20,000 euros in Switzerland. Plus, if you want to import it to the north, you have to pay the customs and the transportation. So maybe some 25,000 euros. Vacuum dryer is also a very good product, but it seems to be very expensive. So I would say that it's suitable for a big group of producers or valuable products, as well as freeze dryer. If we have like 10 or 20 companies who are eager to invest in a freeze dryer, why not? Then you certainly have enough volume to pay the costs. So usually they are expensive, usually the more advanced technologies. So flatbed dryer is in this world still the most popular alternative. But as we have heard, we have to be able to increase the temperatures a bit more than what is now the trend, or what is now the normal normal way. Yes, I think this was my answers to the question.
Okay, Antti will then complement a little bit your answer.
I will give this small compliment for this temperature problem of getting suitable heaters. Within this project, I found up this one company from Finland, only one, which makes custom heaters, and they are not that expensive actually if you are comparing to other expensive methods. And the idea is that they don't have actually that big catalogs, because you can order any kind of heater with any kind of safety features from them that you want, and the cost varies from 100 euros to what you want, thousands of euros. But I asked for some good heaters for drying use in our project for this modular dryer, if it would be driven with electricity, and this heater with was 4 kilowatts and with a blower, so it's a complete unit with a blower and a heater unit, and with thermostat and overheating protection. It was 600 euros plus VAT, so not actually that expensive. And then one compliment also to Evelina for the drying this in oven to determine the dry matter content. Just as an advice, when you are using, for example, a household oven, the temperature is not actually what it shows. So please measure the temperature before you start drying overnight, because it might be 95 or 125. If it's under 100, you don't get dry enough. If it's over, you will start evaporating the essential oils. So it's not just water that leaves the product. So put some kind of a measurement before you start doing that. That's what I have.
Thank you, Antti. Let's see if we still have some, some complementary descriptions. Jana and Evelina, do you think there is something that should be brought up as well? Or did you answer everything?
Yeah, well, actually, I don't know Chaga very well, but I assume that the moisture content doesn't variate so much in Chaga than in herbs. And maybe if you just take few samples and measure the dry matter content with the method Evelina just explains, so drying them in oven, so you get a feeling what the average moisture content is, and then you just weigh the material to be dried and start drying, and then you are if you want to get it to 10% moisture content, then you are able to calculate how much water should be evaporated until the material reaches 10% moisture. As you know already where to start, it may be there might be some 80 or 85% of moisture, maybe 80, and then you just calculate how much water you should get away, and then you just weigh the dried material, and you find that okay, well, this much water has been gone. So you either continue drying or just you are satisfied with the weight. But I would say that what is important to touch the material or crush with your hands if it's possible, and so that you see that all the material on the shelves or on the crate is in a similar situation so that it's dry. Yeah.
Let's check if we still have some additional. Yes.
Yeah, this is something we discussed already.
Yeah.
Yeah, and then only the thing, there was a research made for salvia, a sage, somewhere in southern or middle Europe. So they noticed in this research work that you see in this picture that as if the moisture content in this sage decreases to under 10% and goes near, let's say, what could it be, 2-3%, the öljyhävikki, decay of the moisture or wood is increasing. So they propose that the good temperature for this plant, drying temperature, would be 60 degrees and drying maybe somewhere under 10%, but not more.
Okay. Thank you, Jana. And now I'm really curious if we have got any additional questions. I was notified that there is something wrong with the chat. Let's check it out.
I haven't seen anything on the chat. But...
Yes. Okay, but now, please, if you have any questions, comments, so please feel free. And of course, yes, if when you are muted, please turn on your microphone and camera if you wish, if you would like to ask or comment. Thank you, Tina. This was a very interesting seminar. Thank you very much. Yes, thank you. Lessons learned. Thoughts about this drying and energy topic, or any ideas how to continue? We have been focusing mainly on micro-sized entrepreneurs now, since the situation in Finland and Sweden is such that most of the enterprises are micro-sized, or there are of course some small and medium-sized enterprises as well. But compared to the enterprises and the businesses in Central and Southern Europe, we are just in a starting point. But Central and Southern Europe, the traditions are quite long, 30 to 40 years, and the sizes of enterprises can be like 300. The turnover like 300, 400 millions per year. So this is really the reason that we have been focusing on how to help micro-sized entrepreneurs to get this business started.
Yes, and I would like to say that from Hushållningssällskapet we will continue this journey towards developing businesses within the drying area. And if we still have some Swedish listeners, you are welcome to contact me or Håkan, and it will be possible in the future to use this dryer in Öjebyn if you like to try out drying. So, it was
Okay, thank you, Helena. Any other comments or questions? Like I said, I will send you an email with the link of the new video once it's finalized, the video, and with there you can listen to the interviews of the entrepreneurs and project partners, and then if you can give any comments regarding this webinar, it would be nice. Also, we would of course like to get the feedback how to enhance when we are planning for the next webinars, because this is the future. It will be hybrid events most of the time, hopefully more and more on-site events as well. But once we have managed through these difficult times, I believe that it will be hybrid events. So it's both on-site and online. So all feedback is, of course, we appreciate that. Okay, if you don't have any questions or comments, so I thank you all for participating in this webinar, and I will end the recording now.